In this video, we're going to be doing some momentum and impulse calculations. We're going to be focusing on a force versus time graph, and then we're going to be solving for three different things. Number one are impulse, and then 2 and 3 have some specific situations where we're solving for a velocity. Now, for a force versus time graph, the main component that you would need to know is that if you take the product of force and time, that gives you the impulse. And generally speaking, if you're finding the product of two numbers and they are being graphed, then you're going to find the area underneath the curve. In this case, it is a triangle. So and oftentimes in a force versus time graph, it may have some sort of a spike because there's sort of like a compression and decompression of some sort when something is experiencing a force for a certain time. And for this one, we have a force that peaks at around 30 newtons, and it goes for about 3 seconds total, from 3 to 6 seconds. So we can go ahead and solve problem number one. What is the impulse? And that's basically finding the area of our triangle. So it's just basically 1/2 base times height. And then the base is 6 minus 3. So it's basically just 3 seconds that it's elapsing. And then the height is going to be 30 newtons. And then that's going to equal 45 kilogram meters per second for our first solution. So as I said, depending on the type of curve or shape that you have on your graph, you're basically going to find some areas of some rectangles or triangles. Now getting into number two, for number two, we're looking for a VF. And if you're looking for a VF, then you're going to use a formula: impulse equals mass times delta V, which delta V is final minus initial. Now, we already took care of the impulse portion of it, so we already know that it's 45. And then it says we're looking for the final velocity of a 5 kilogram cart that is at rest. Okay, so it's initially at rest, and it has some kind of final velocity later, so it's 5 kilograms. And then we're looking for the final velocity if it were starting at rest. So this one, basically some simple algebra. We can just divide both sides by 5. And then we're basically done because the minus 0 isn't very significant. So then we have 9 meters per second for our final velocity. Now our third and final calculation, we're looking for the initial velocity of a 2 kilogram ball that has a final velocity of 4 meters per second. Again, it's experiencing this impulse from this particular force for that period of time. So we have the impulse of 45 still. The mass changed to 2. And then we have a VF of 4 minus our initial velocity. Now for this one, we could either distribute the 2 to both of these, or we can divide both sides by 2. I'm going to go ahead and divide both sides by 2 first. And that would leave us with 22.5 equals 4 minus VI. So if I subtract 4 from both sides, then this becomes 18.5 equals negative VI. And then if I multiply both sides by -1, then this becomes negative. And that solves for my VI. Comes out to negative 18.5 meters per second. So number 3 is actually a bouncing problem because the initial velocity is negative 18.5. So it would be something like this, where it's coming in at negative 18.5. It experiences a force that peaks at 30 newtons and then drops down for a total of 3 seconds for the time of impact. And then it gets bounced backwards with the final velocity of 4 meters per second. So one of the things with impulse is making sure you're aware of the directions, and if it has a different sign for the velocity, that means it's a bouncing problem because it's going in the positive and negative direction, or vice versa. So again, when taking a look at these force versus time graphs, if you find the area underneath your line, then you can find the impulse, which is a change in momentum, plug it into one of your formulas, and then solve for an unknown variable. So I hope that was helpful to you. Thank you for watching and listening.